On page 6.4, we will be doing geometric applications of our exponent rules. So I will write the formulas that we need off to the side as we're using them. So for 16, we have a rectangle. There's a couple of different ways you can find the perimeter. One is you can just add all the sides together. So you would need to add in the 12x and the 5x squared here. And you can just put those together. If you want to use a formula, which I'll show you here, there's two different ones. 2L plus 2W, or you can do 2 times L plus W. So I'm going to go ahead and do the first one. So I'm going to do 2 times 12x plus 2 times 5x squared. So that would give me 24x plus 10x squared. And you cannot put those two things together because the exponents don't match. The area of a rectangle is just length times width. So for area, we would have 12x times 5x squared. So we would need to remember we multiply our big numbers, our coefficients. So that's 60. We add our exponents, x to the third. 60x to the third would be how we would write the area. (17) and 18 use triangles. So for triangles, your perimeter, you're just going to do side 1 plus side 2 plus side 3. So if it helps you to write it all out, you can do that. 4a squared b plus 10a squared b plus 3ab. If you don't need to write it out, you can just look at it and find your like terms. That's fine. So only your first two here that I wrote are like terms. So we would have 14a squared b plus 3ab. The area of a rectangle is 1/2 base times height. So your base and your height have to meet at a right angle. So in our triangle, that would be those two. We will not use the 10a squared b. So the area is 1/2 times 3ab times 4a squared b. So we multiply our big numbers. 1/2 times 3 times 4 is going to give us 6. And then we add our exponents, a to the third, b to the second. So remember, you can always add a 1 for the invisible exponent. Number 18 doesn't have all the sides labeled, but it says assume it is equilateral. That means all three sides are the same. So actually all we have to do is take 3 times 20m to the third n to the fifth. Okay, that's the same as adding those together 3 times. So it's easier just to multiply it by 3. So we get 60 m to the third n to the fifth. The area would be 1/2 times 20 m to the third n to the fifth times 4m n to the fifth. So our final answer would be 40 m to the fourth n to the 10th. For 19, we have a trapezoid. You can split this into a rectangle and 2 triangles if that's easier for you. But the area of a trapezoid is 1/2 your height times b1 plus b2. So base 1 plus base 2. Your bases are the two that are parallel. So in our case, we would have 1/2 times our height is 2xy, parentheses 4x squared y plus 7x squared y. So it's a lot to write out. I'm going to go ahead and put these two together on the outside to give me xy. On the inside, that gives me 11x squared y. So remember, when you add or subtract, you do not change the exponents. So this is all multiplication. It looks a little bit scary with the parentheses. So if you want to take the parentheses away, you can just put multiplication signs into everything. So we have 11 x to the third, y to the second. And our last one, our circle, the area of a circle is pi r squared. R is your radius, which is halfway across the circle. So that's what's labeled. So we are going to put pi in parentheses 3xy cubed squared. So whatever your radius is needs to go in parentheses. So we leave the pi out front. 3 squared is 9, x squared, y to the 6th. So the only thing you want to do to make this a little bit nicer is put 9 pi x squared y to the 6th.